Good evening, everyone. Welcome to SITAC webinar series. This is Rakesh Malakar, a core member of SITAC organizing team. We have a very important presentation today on infrastructure architecture. Our special guest today is Urmi Kavi. She is a senior IT architect at Puget Sound Energy. She has extensive experience and expertise in infrastructure architecture. She was also one of the mentors for PAS2 competition. She also serves on the board of directors of Executive Development Institute (EDI), a Pacific Northwest nonprofit organization committed to building a community of diverse global leaders. Before we start the presentation, few housekeeping details. If you have any questions during the presentation, please type them in a question box. During the presentation, Urmi will pause for the questions and I'll read questions on behalf of you. Urmi, take it away.
Thank you, Rakesh. Welcome to the fourth ISAC competition, architecture competition. Like Rakesh said, I have been working as an architect for quite a few years now, and infrastructure is my specialty. I also do solution architecture and enterprise architecture work. As an architect, I'm familiar with the different domains and different areas of architecture that come into play when putting a solution together. I'm hoping that everyone is having a lot of fun in this competition. If you are so far along, congratulations. You're in the home stretch. In a couple of weeks, I think the final presentations are due, and then the scoring will come after the final presentation in April. But coming along this far is very, very impressive. So you should all be very proud of yourselves. So we'll start the presentation with some agenda items here. Again, I'd like to keep it very open, so please ask questions along the way so that they can be addressed. Or if you see something that's not on my deck, but you have a question about, feel free to ask about it. What is IT architecture? I feel like if you're talking about infrastructure architecture, I want to make sure I touch a little bit on IT architecture. And I know that many of you may have attended several other presentations along the way from other mentors and architects who are volunteering here. So maybe there's some overlap there, but I'll try to keep it short. I want to explain what IT infrastructure architecture is. And I'll touch a little bit on how that is changing and evolving. IT infrastructure capabilities, that is the core piece of infrastructure architecture. And then where do you start when you've got a solution and people are going to ask you to put a technology stack together to pull the entire solution together to align with the business objectives and goals. So what is IT architecture? The definition is what the ISAC community has in mind, and I'm not going to read my deck there, but basically IT architecture's main purpose and the value proposition we bring is to create value for the business. So architecture, IT architecture is dealing with ambiguity, dealing with complexities, dealing with uncertainties and unknown, and looking and peeping into the future to see what can happen or what is necessary to align with the business vision, the business strategy, business goals and objectives, and also having a broader view of what is happening in that industry. So it is not enough for architecture to know what technologies are out there, but architecture organizations are also expected to understand where the business is going. So we literally are partners with the business to help them define their vision. And then as architecture in the IT space, we come back and then map out the capabilities needed, followed by the technologies that are necessary to deliver the value proposition that the business is seeking. So what is IT infrastructure architecture? You may have heard about what is, you may have heard the term technology architecture, or you may have heard what is called domain architecture, and infrastructure architecture falls in that phase. So it is basically modeling of the hardware components and elements and technologies across a common platform. And when I say a common platform or across a common enterprise, it's an organizational level capability or technologies that you're thinking about. You're not going to be thinking specifically just for one particular solution. And it is mapping the relationships between them to support, again, the business objectives and goals that the business puts forward. So if you think about some core pieces of technology, I'm just going to throw them out there. You've got your compute, you've got your storage, you've got networking, you've got firewalls and infrastructure security controls, and those aspects of it all come together to pull a foundation on which the application and databases can run on to then deliver the business value to meet the business objectives. Some key drivers and considerations that should be kept in mind when it comes to infrastructure architecture. I think this is true for all businesses, but in general, if you are working on a architecture solution that you're going to propose, think about cost. And I cannot emphasize for infrastructure why this is so important, because storage and compute and certain platforms can become very, very expensive, sometimes even more expensive than the overall solution. So these costs have to be kept in check. And people, as architects, you have to make sure that the costs are not going to be so exorbitant that the whole solution becomes cost prohibitive and you cannot implement it. IT security is another area that is key and critical and almost ingrained into the entire technology stack, but is also important for infrastructure because you want to make sure your servers are protected. You want to make sure your storage, the data that is stored on the storage platforms is protected at rest and in motion. You want your networks to be secure, and you want your firewalls to have the right controls and ports in place, configured so that the right appropriate traffic is allowed in and out of your organization. The last piece is regulations and compliance. We're living in an evolving environment where government regulations are changing, state regulations may be changing, financial regulations change, and they all impact how a solution is implemented. And it also applies to how a server is managed, or how a storage is archived, for how long do you have to retain the data that's there. All those requirements are dictated by compliance and regulations. Each industry will have their own regulations and compliance. For instance, utilities has NERC, healthcare has HIPAA. You may have heard about credit card processing industries that have PCI. You've heard about PII. And now, if you've heard about Europe, they've got the whole new governance, privacy governance regulations that have been published, which a lot of US vendors, software vendors like Microsoft and others who do business in Europe are scrambling to put those in place. So compliance and regulations also play an important role in how infrastructure is designed and developed for a particular solution. So what are some of the infrastructure capabilities? And capabilities are similar to, maybe you may say, core competencies that need to be in place for a solution to work. The first thing I'm going to point out is data centers. And along with that same concept there with data centers, I'm also going to point out that data centers, for some of you may think, oh, it's in the cloud, so I'm going to put it in Amazon, or I'm going to put it in Microsoft Azure cloud, or a Google cloud, or it's going, because on-prem in someone's data center is becoming more and more obsolete. That is very true. But at the end of the day, we are either leasing in in someone's data center, or we have our own on-premise data centers. I want you to take that concept away with you as you're thinking of developing your solution as to where you will actually physically host your solution, be it in a third-party provider's data center, or it may be your own data center because the company is large enough and wants to build their own. I will make a note here that the trending is towards the cloud providers, meaning consumption of these services in someone else's data center. So if you have a data center, and this is, it doesn't matter whose data center it is, some things to keep in mind, and you're going to be like, well, why do I have to keep in mind? Well, here's why. Because at the end of the day, how available that data center is means how available your application will be, because that also falls into your entire solution stack, even though you may have nothing to do with or nothing to manage there. So you want to make sure there's dual redundancy in power. There's enough, your rack space to host your servers. And the HVAC, which is the cooling and heating components, these all make up the environmentals within the data center in which the servers, networking, and other infrastructure technologies are hosted. So it is very important to figure out where this is, because you may have, again, if I go back, map it to the regulation requirements, there may be mandates that the data cannot leave North America, which means that now physically your data can reside only in data centers in North America and not elsewhere. And a lot of cloud providers have data centers across the globe in various continents, and the ability for data to move or be saved in all these different data centers. So these are some considerations to keep in mind as you're either negotiating with cloud providers or third-party data center providers, and also when you are designing your solution for availability and disaster recovery. Capacity planning. This refers to the usage pattern. So when we look at, let's say, a compute platform and is implemented at an enterprise level, we are going to be looking at usage patterns, meaning, let's say you've got an enterprise application and you realize it's got a certain amount of allocation and it's consuming only 70% of what was allocated to it. So you have some capacity there. And if as that application grows, you can look at the trending there and figure out what the growth patterns look like. And once you start doing this across all your entire application portfolio, that's what helps you figure that out for capacity planning of what that is. Now, you may say, well, that's for the enterprise level. How does this help me for my application that I'm building? Well, here's the thought process there. You want to think about capacity planning as what are some of the key things that if we add new capabilities to the applications or the system that is being built, how will that need for compute, storage, and other elements of the network, of the infrastructure stack will change. So think about, and as you grow your solution, you may add more data, you may decide to add more features. All that creates more information that needs to be captured somewhere. So then as the maturity of the application and the usage grows, the other areas of infrastructure need to be taken into consideration as well. And so you want to keep that in mind for cost optimization so that you don't over purchase capacity. And at the same time, you do not want to under purchase capacity for compute, storage, and other platforms that make up your infrastructure stack. Networking. Networking is the connectivity aspect of the infrastructure. So you have connectivity within the data center, which is the local area networking. And when you have connectivity between different data centers or remote offices, or with the end user computers at different locations other than the data center, you will have a wide area network that comes into play. And I mentioned telecommunication services because not everybody will have connectivity between the data centers that is owned by the company. Telco companies have to be used, like your internet service provider or some fiber providers that help move that data from the data center to other locations where it needs to be consumed by the end user, or to another remote office, or wherever else it needs to be made available. And I mentioned the telco service providers because those can be services that take a long time to set up, and they're third parties. So negotiating with them is important and critical. Again, just like the cloud providers, you want to take into consideration resiliency, redundancy, and the regions in which they can provide the service, because you're relying on someone else to help your resiliency for the solution to be available. So you may have two data centers, but to connect them, a telecommunications provider, a telecom provider may be the one who helps you move your data from one data center to the other. And so you want to make sure that they have the resiliency that you're expecting and the redundancy, so that you can move your applications between different data centers. And this also is true for cloud providers. This is some similar questions to ask if you want to put your system in Oregon and Virginia, or East Coast, West Coast, or in Ohio or California or wherever. You want to know and understand how will my data go from that one data center in, let's say, Oregon to California, or California to Oregon, and vice versa. Device management is part of infrastructure. This is more in the end user space. So you're looking at form factors like phones and laptops and desktops, and you're probably saying, who has desktops today? But there are some places where there are desktops. And why is it important to understand what device management is? We have a lot of mobile devices, and then as we grow with IoT, there's more devices that come online. Managing these devices is important. It is important for the end user experience, it's important for the security, and it's important to understand the form factor on these devices, because that dictates what your solution stack will look like. If it's a mobile, if you're writing a solution which will be accessed by users using a mobile phone, you want to make sure the website will form to a mobile phone, be it an Android or an iOS phone, and then different providers have different models, and you want to make sure that those devices can be managed and can be kept virus-free, so that your end users will have a good experience. The same thing is true for desktops, and also for other form factors like tablets, which may be used by field crews during maintenance and support activities. Because they may be taking pictures, and then they need to attach it to an application and upload it on a website somewhere. So keep those aspects in mind. And then managing these form factors is important from security perspective, and also for data loss. You want to make sure that it's secure, so that the data on these devices is not lost. And then the last but not the least, the end user experience has to be good. The next is disaster recovery and backup. Disaster recovery, so disaster recovery in general refers to a situation where there's a disaster, which is either natural or man-made, caused by natural or man-made reasons, due to which the application or the business process is interrupted. And so there has to be another way to reduce that downtime and make sure that service continues somehow. It may be in a degraded state based on agreement with the business, or it may be not available at all, which is fine too. Or there may be a duration that the business agrees that we can be down, and their agreement is to take the outage, but then they want the service to be restored in 2 weeks or 3 weeks or whatever may be the case. Depending on the use case and the scenarios that the business agrees to, Some businesses are 24/7, 365, which means they cannot afford to take any downtime. Some examples of those businesses would be Amazon.com or Netflix, or pick a website that's 360, or a hospital, right? They're 365 and they cannot 24/7, and they cannot have an outage. Whereas, and that is now becoming almost a norm because of the internet. We no longer see sites that say under construction will come back and check on in 3 weeks or 4 weeks, something we saw in the 90s back in the days. So now the expectations have changed. So if you're an online business, it's definitely 24/7, 365. There may be some small outage durations, maybe because they're patching or something, but even then they have most of the key functions available, and maybe some of the services may not be available because they're doing some back-end maintenance. But you want to make sure that your application and solution is able to meet the business's recovery point objective and the RTOs and RPO objectives, so that the system is available. And as you're designing your solutions, your infrastructure will need to think about it. Will need to take those things into account. For example, you may have redundancy and HA pair in one data center, or you may have the HA pair across the data center, so you stretch it out so you'll have less infrastructure costs if your application allows. Or you may go full-fledged, and you may go, you have an HA pair in one data center and an HA pair in your backup or disaster, your recovery data center. So you've got a full-fledged solution across the board. All these different combinations of use cases and the type of infrastructure you do decide to go with will have costs associated with it. So as you're designing your infrastructure components and solutions for disaster recovery, keep those in mind. Backups are core to disaster recovery. Backups is best practices. Systems should be backed up on a weekly basis, or at least incremental backups every day, or maybe some core systems components are backed up on a regular basis. Your disaster recovery processes may also include restoring systems from backups based on the criticality and the classification of the process. So something to keep in mind, not everything is tier one, not everything will get the prime funding, because you do have to classify different processes based on the criticality and the business classification of priorities. And so you may have a combination of different services, infrastructure services that you offer for tier one applications over to tier two and tier three and tier four. And the same thing is true for storage. You can have the most expensive flash storage for your tier one applications, but then you can have tier two storage for some other tier two applications or non-production environments. You may have some cloud elastic services kind of storage, which is a lot cheaper, and that is where you put your archiving data, which is something that's asked for maybe once every 2 years or 3 years for audit purposes. So keep those in mind, how when you architect and design your infrastructure components, how those come together. Operations, the SLAs, OLAs, and monitoring. So SLAs are service level agreements in operations. OLAs are operational level agreements. These are both ITIL terms. If you're familiar with ITIL, or if not, then feel free to look it up. It is it's a way of classifying services and service management aspects that was developed in UK by the UK government, and it has been widely adopted, especially in the IT infrastructure space, for change management, release management, service management, and there's several components of it that align nicely to infrastructure processes. And some of it is also used in software management as well, especially the release management module is used for the release cycle of software packages or software capabilities management. These are usually defined within the organization between the IT support teams and the business. This is very important to think about. So once the developer and a team of programmers, a team of project SMEs, a business analyst, a project manager, an architect, infrastructure engineers, they all come together to design the system. It's done, it's working, you've gone live. Well, post go live, there's still nurturing and caring and maintenance of the system that needs to happen. And that is where the operations teams come in that perform these support and maintenance activities to keep the system up and running post go live. So, and these are important things to do, because if a project finishes and gives us a system goes into production, but there's nobody there watching it. So when there's failures or when things don't work properly, if there is no one out there keeping an eye on it to keep it updated, then it's going to fall apart, and the service level agreements will not be met with the business. And so that turnover from project to operations is very important, which is where the operation level agreements and the service level agreements are negotiated between the business and support teams. Monitoring is another key component. All the infrastructure components like servers, you've got your storage, you've got your networks, firewalls, load balancers, and all the other components that make up the infrastructure stack should be monitored. And by monitored is on a server, you want to ensure that the CPU utilization, if it reaches 80%, you want to be alerted to make sure that things aren't going to tip over and break. Same thing with disk utilization, or maybe there's some storage allocations that need to be monitored, file shares need to be monitored. Maybe there are services that have been scheduled in your software that need to be running at certain times, like a batch job. And if it fails, you want to be notified that it has died, or you want someone who's doing 24/7 365 days monitoring gets alerted so they can look at it and keep it up and running. So depending on the criticality of the application, monitoring needs to be in place holistically, preferably across the whole solution, including application performance monitoring, so that if your application is running slow or there are some sluggish behaviors in the application, then those get identified, because the application is going to consume the infrastructure resources, and it is generally a good indicator of what is going on. If you have memory leak problems, or if there's certain modules that are services that are not releasing memory, and that is causing the servers to tip over, or some of the integration services are not designed properly, then those all come into play in how the infrastructure will respond, because it'll start getting consumed at 100% capacity, and then you will have to bring in more capacity to add to it. But if you don't know what the problem is, then where do you know where to add? You add more servers, if you need more bandwidth, or you need more storage, or what is the real problem? So monitoring gives you that. Monitoring also helps you with testing, because when you do testing, performance testing in particular, if you have your monitoring tuned properly and set up with the right configurations, then that is a good indicator of whether your tests are successful or not. So before I continue on, I'm going to stop for a minute here. Any questions by the team?
We have one question from Rahul. Just a second. So he's asking, does IT infrastructure encompasses network architecture, security architecture, and technical architecture? What he means technical architecture is what type of technology that will be used in infrastructure.
Sorry, guys, I'm still recovering from a sinus infection. Hi, Raul. Thank you for your question. So, technical architecture is a term used by TOGAF for infrastructure architecture and security architecture. Those are considered domain architectures. So, if you've heard the term, there are domain architects, solution architects, and enterprise architects. Well, domain architects is where we have our infrastructure architects. So that's where infrastructure architecture comes in. Network architects, again, network architecture is a domain. Security architecture is a domain because security, it encompasses the whole solution stack, but that is where it is considered a domain architecture or technical architecture. Those are kind of similar terms used to describe the same thing in a way. So, yes, infrastructure architecture is a broader term that includes servers, storage, virtualization. It also includes networking and security. So the different companies may give it different org structure names, but in general, in the industry, when you say infrastructure, people will ask you, well, what do you do in infrastructure? And then people will say, well, I focus on servers or network, or I focus on security. And so those are the different subdomains or other domains of infrastructure architecture.
He said,
Any
got
other
it.
questions?
He said, got
Okay.
it. Thank you.
Okay, sure. And please keep the questions coming. I'm happy to answer them along the way. And I'm trying to keep this as organic so that it's a dialogue instead of me just giving out definitions to the team. I'm trying to keep it open so that, you can, I want people, if it's nothing else from this competition, I want everyone to become really great thinkers of, if I do this one thing here, what is it going to do overall here? So if nothing else, if you take away one thing from this presentation is architecture is a thinking job. And so all I ask is think big.
Absolutely.
So moving on, security architecture is also part of infrastructure, and I'll touch on the infrastructure side of security aspect. I was informed that there was a security architecture session yesterday or day before, so a lot of this may have already been covered in that section. And by no means am I a security architect. I'm putting out the disclaimer. But however, I feel very strongly about security, and I cannot talk about infrastructure without including security because it's core and very essential to infrastructure and also the overall solution that gets put out there. So security control become a big deal. There are so many ways of figuring out or putting controls in your system. So when you put the solution stacks together, and I'm going to start from the infrastructure level. So we've got our server. On the server, there's the operating system. There's virtualization layer. There's antiviruses that need to go on there. You can put a HIS on there. So there's a lot of HIS is like an intrusion detection system, by the way, that tells you if there's penetration, if you've got viruses on your computer, it either blocks it or changes the configuration, or it, if nothing else, it at least alerts you that something's gotten into your computer and you've got issues. But its primary function is to be configured such that it can block it. So you have to have antivirus. I think almost everybody who owns a computer these days knows that you've got some sort of antivirus on your computer, on your laptop or your desktop or whatever form factor you're using. And malware is another one, to make sure that you've got blockers out there that blocks out the malware, keeps out the bad guys from taking hold of your computer, because that's happened too, where computers and systems are being held hostage. And then the ransomware comes to mind, which was, I think, about 2 years ago or a year ago or so, where companies were asked to pay money before they could get their data released back to them. And then another thing is you don't want your data stolen, right? You don't want your passwords locked. You don't want your system important confidential data that's residing in your databases, in your applications, be stolen because they weren't properly protected. So infrastructure, making sure that it is protected is very, very important. The other piece, firewall, same story. You want to make sure that your firewalls are your first line of defense from the internet or the level 0 security. If anybody is familiar with the zoning model that's out there, which is like probably several years old now, but it's your first line of defense. And you may have multiple firewalls depending on the design of your security posture. But it's like your front door that allows things to come in and allows things from your organization to go out. And so you want to make sure that your firewalls are redundant, resilient, are able to protect you and allow only what needs to be allowed. So shut off ports that are not necessary, and make sure that the information that is coming in and going out is what's appropriate. Access and identity, this is part of AD. So if you've heard the word, a server needs to be connected to a domain. I think this concept came around the 90s when we started doing the 3-tier architecture. You've got your web, you've got your application, you've got your database. And so once at a very high level, these servers then needed to be networked, connected to a Active Directory. And so with Active Directory comes account management or account lifecycle management, be it for the user or also the service accounts, which are necessary to run your databases or maybe your applications or certain processes. All need anything that uses an account in Active Directory needs to be managed through a life cycle. So from start to I want to say decommission, and that's the entire life of it. Because you may decommission a module and it doesn't need that service account. So now what do? Do you disable it, delete it, or whatever it is, however you choose to sunset it. And the other thing to remember with access and identity is role-based access control. It is very critical that only the people who need to know have the right access to the right information at the right time. So access should be granted on need to know basis. Not everybody doesn't need to be an administrator. Everybody doesn't need to be super user. So you have to figure out your groups of people based on their role and the functions they will perform on the system and make sure that they get the appropriate level of access. So your end user doesn't need to be able to be a super user who has access to your databases or have the ability to log into your servers and make software and be able to add software to the server. Those aren't functions that an end user would perform. But they do need to be able to create and fill out an application form, for instance, then that is the level of access that is necessary for them. Program cleanup, and by that what I mean is if there's unnecessary software that's sitting on the server, or even better, when a system is being built, you may have contractors and you may have developers and you may have other people working on it. And as builders, we have our tools and we install them on the servers to help us build the system. That's great. We're done doing our work. We take our tools and uninstall them. Just like how when you build a home, there's an electrician that came and did the electrical work or a plumber that came and did plumbing, and they brought their tools. But when they leave with their tools. So same story here. If a server or any hardware, be it a network switch or a router or any other devices, or even on a firewall, sometimes you have people who come and do some audits or they come and do some reviews. But when they're done, you want to remove that software so that is no longer needed. If it's no longer needed, it does not need to be there. That's just part of cleanup work. That's just best practice, because the minute you leave those gaps around, they become problematic over time. So those are all maintenance and support activities, which I was referring to earlier, which is why you need an operations group that takes it over and makes sure that the system stays pristine and operates at the desired level that the business expects it to operate. So where do you start? You're probably going, yeah, she went over a whole bunch of stuff. That's a lot of information, but how is this going to translate into what am I doing for this competition? Well, make it easy on yourself. Figure out what the requirements are. And I think you all did that in probably November, December timeframe. You documented your business requirements and the system requirements, and then map those to technical requirements. So understanding that if the business says we're going to be open 365 days, 24/7, that means your system needs to be available at all those times, which means now your technical requirement is that you have to have a primary and a secondary data center at minimum, so that you have logical separation, physical separation for your hardware, and geodiversity. And by that I mean that if your one data center goes down because of that disaster that I was mentioning, either man-made or natural, you have another data center which can just come up and take in all those systems and keep the business continuously up and running. So that is just one example, but I'm sure you've got at least 10, 20 or more requirements. Start thinking about it and start mapping those from the business requirements to system requirements to technical requirements, and then those will translate into your hardware specs or the building materials list of, I need a server that I need 5 application servers, I need 5 database servers, I need 5 web servers, and then I'm going to split the pair out this way: 2 in data center 1 and 3 in data center 2, and then A and B to make it easier. And then you can go back and forth, figure out what your stack is going to look like between geodiverse data centers. I cannot emphasize that, how important that is, because you want to make sure your applications are available 365 days, 24/7, if that is one of your requirements. So think about it in those terms and go through your list and make it easy on yourself. That's one easy way to not miss anything. So key things to consider. This is, again, you've got your infrastructure stack. I can guarantee you, if you go in the real world and start working as in IT, one of the first things you'll hear is there'll be money allocated for a project, there'll be a work order number, and the first thing people will run out and want to do is buy a server. I guarantee you. And I'm not making that up. That is the first thing people think of, because now you have a number, you've got a charge code and I can spend money, and that's what people want to do. But that is not the right thing. That is, you want to follow the process, which I mentioned. So as you're going through your process, as you're doing your application, the system application requirements dictate your technical requirements. So if your application is maybe .NET stack, then Windows is a better, perhaps, Windows is a better operating system for you. But if your stack, application stack is written in Java, maybe Linux is a better option. Or if it's a database, you may want to use Unix or AIX for the server OS. But based on your application, again, system requirements, those will decide what your technical requirements will be, meaning what is your operating system, what are your hardware requirements for the server, meaning what is your CPU utilization, your RAM requirements, your disk space requirements, some of the very basic pieces that form our server. Next thing is storage. How much storage do I need? And again, classify your storage into tier 1, tier 2, tier 3, or another way to look at it is also hot, warm, and cold. So hot is something you need right away. Warm is something that can be like for reporting or those kind of systems, and it can be a second tier, lower cost storage. And then cold is something that's archiving, and that's data that's retrieved. That can be slower performance, or it can take a little bit of time to come up. Then you can put it on a cheaper storage layer. So that's one of the ways to figure out how to manage costs, because you're not going to get unlimited costs, unlimited budget to run the project and put the infrastructure in place. So networking, we've talked about connectivity, and I mentioned the LAN and the WAN and the telco providers. But another thing to think about is bandwidth. What are your bandwidth requirements between the two data centers, between the servers and the end users? Those are some critical things to think about, especially if you have graphics heavy applications, or you have applications that do real-time processing, or like, for example, real-time processing would be trading. Like if you can think of the stock market systems or the power grid systems or any other place which is where things are changing in real time. And the reason why I'm trying to think of that is because with IoT, there's a lot of data that's coming in, and those things are coming in through some network somewhere. So figuring out how those sensors and those devices are bringing data back into your data centers, and then how is the end user experience going to be when that data is aggregated or compulated and displayed to the end user, or when the end user is pulling out your website or bringing up your web application views. You want to make sure that you understand what the bandwidth requirements are there, so that the end user experience is acceptable to the business. And the business will sometimes, actually, we've had people who come and say, I want it to be under 2 milliseconds, or just some crazy numbers they come up with. But when you actually do the test, you will realize how you can tune your applications and tune your networks to meet those requirements. And then last but not the least, of course, security. Don't forget security, because it is not an easy conversation to have with the CIO or anybody else when you have to explain why somebody broke in or came in, hacked into the system and took away data. And I think all of you have heard about these online and in the news all the time. You see credit card information stolen. It's not just the stolen fees, because now people's lives are disrupted because of the loss of this data. And then for the business, it's like you made the 6 o'clock news. Like, that's not enough. Now you've got your goodwill on the line, and it's an embarrassment, and it's the costs are just so astronomical that it's become imperative that security controls are thought of upfront, including in the application layer itself, instead of as an afterthought. So that's what I would suggest, that think of your business requirements, think of your system requirements, and then your technical requirements will fall in place for infrastructure. So this is a link to anybody who's interested in learning more about infrastructure architecture. ISA has a certification. There's a website. There's books you can buy and read and learn more about it. And of course, Google is a good resource. I'm just going to throw it out there. Go out there and type in whatever you need to, and you will get lots of good articles from Gartner and the vendors themselves. There's a lot of good blogs out there, lots and lots of good information out there about infrastructure architecture. I don't have anything else, so thank you. But I'm open to questions or anything else people have to say.
So anyone, if you have any questions, please type it in the question box, and I'll read it to Urmi. I don't see any questions, so you...
Rakesh, be good.
Yeah, I think so. You explained it well.
Well, thank you all for joining today. I know it's not easy with the time zone. I'm in Seattle, and I think the rest of you are all over the country. I really appreciate you taking the time to join this webinar and joining this competition. That is just awesome. I'm hoping that you have an awesome experience, and maybe you take away a few things. And all the best for the competition, and maybe I'll see you guys on April 6th, I think is when the finale is. So all the best, and good luck with the competition.
Thank you, Urmi, for a wonderful presentation this evening. Thank you so much. Thank you all.
Thank you. Bye.
Bye. Good night.